twala konkanyapo para tuapelele and root twala send anili yako bati twala lo shapadi operation ya electrical control circuit for both the and crusher lubrication control na crusher main drive control, because I have interdependent in the way they work. Okay, so ngamwamo na okay apa I'll just be referring to ama rungs. Okay, ama rungs like ladder rung 3, 4, 5, 6 and whatnot. There are rungs in the way that they've been arranged, like ngama lolesha yale moneka kwa mass steps ya ladder. So this is ladder rung number 3 because the 3 is down here. Okay, and then here you last ladder rung number 16. So mwala mona tuyonsaya yadi labeled ama rungs yonsaya. And also you notice that just underneath the ladder rung, okay, paleba ututuma contacts ututu the punch up. These, whenever you see these, just know that my auxiliary contacts here are my control relays. Okay, that's where they belong. They are basically just auxiliary contacts for the control relays. So don't get confused about this, in the sense that, for instance, that E control relay 3BD6 down here that it's been used in the rung number 4, 10 and 29. Moody number 4 is being used as a normally closed contact. So 3BD6 is used as a normally closed contact. Actually, this was a mistake. It's supposed to be normally open, in the sense that E3BD6, the normal condition here 3BD6, if we look over constantly energized under normal operating conditions, which is why Ngaidi normally open and this is constantly energized, so this normally open contact is supposed to close, which is the only way mwalamba E system, because Ngamawomfia normally closed mudi rung number 4, then this will always be open tetimwambe. So mudi rung number 4 is used as normally open. Okay, and then ngamwaisado le shapari mudi 10. Okay, so 3BD6 is used as normally open, which is again the same thing, or maybe it could be no, this is open, this is closed. So these 4 and 10 was supposed to be open. Okay, in this representation 4 and 10, they were supposed to be normally open. I don't know if this part is editable. Apparently it's not identified as something which can be edited, so we'll leave it at that. But we just need to understand that Moody rung 4 and rung 10, they're supposed to be used as normally open, because clearly they've been used as normally open contacts. Okay, I don't know how they messed up this thing down here. And then if we look at 3BD1, we'll learn that Moody rung 5 is used as normally open, rung 7 as normally open. So 3BD1, we're looking for rung 5. Yes, it's used as normally open. And in rung 7, it should also be used as normally open, which is correct. Okay, so now that we've got that out of the way, we can just briefly go over how this circuit works. Okay, so mwala monat mudi rung number 3, it's just talking about protection, because yonsaya my emergency push buttons. Okay, system emergency stop, stay put, lockable. Okay, so it's those which when you press it latches and then you have to unlock it. Okay, but apparently in this case it's also got that lockable function. So that's the first part. And then to simplify things, we just understand that mostly we can just think of any control system as having a sequence part. Like for us, we'll think of it in 2 terms. There's a particular configuration which deals with the sequence, okay, how the system is supposed to start. Ichambila poni chisa, olopa konka chisa, and whatnot. Okay, so that's the sequence part. Then, kwaisabana part dealing na protection. Okay, then in this particular case, to identify protection, it pama types yabidi, in the sense that there's that protection which just basically shuts down the whole system irrespective of the sequence. Okay, mkwebati ngamasalo le shapali emergency ibaleba safety relay. Okay, this safety relay, which is a consequence of IMA emergency push buttons 3BD6. 3BD6 ile bomba mudi network 4 na network 10. Okay, so mudi network 4, you notice that it's a key element. Okay, 3BD6 is a key element. So if 3BD6 opens, it disrupts the sequence control relay. And then again, 3BD6 will open the lubrication system. It's going to just de-energize the lubrication system. So you notice that E3BD6 has got an operational influence by the sequence control, and then it also has an effect on the individual drives, like lubrication pump. It will stop the lubrication pump. So let's look at the main drive. Also in the main drive, Mwamonapa 3BD6 is going to stop the main drive. Okay, this is the main drive control. So 3BD6 yala iminika main drive, then yala iminika na lubrication control system. Okay, but kulabama faults. Okay, like if you look at all the faults related to the lubrication pump by way of 4DD1. Is it 4DD1? Yes, fault strip auxiliary relay. 4DD1 is a consequence of protection functions via lubrication pump, like the thermal overload as represented by 4DE3, and then we've got the earth fault relay, okay, as represented by 4DE2, and then also we have Ibaleba 3BD5, which is basically a no flow condition, like a lubrication pump na yamba, but there's no feedback to say that the oil is actually flowing, which is what 3BD5 is for. Okay, 3BD5 is here. Okay, this is 3BD5. 3BD5, you notice that 3BD5 has got 4DD2, and then it's got 3BD5. 3BD5 is a seal-in contact of 3BD5. Is an auxiliary contact of the actual control relay 3BD5. Okay, so this normally open contact is an auxiliary of this control relay, right? They're not quite enough 4DD2. So what's your issue? But 4DD2, where are you? 4DD2 is this one, the main drive delay timer. Emgutilati lubrication pump ngayamba. Okay, by way of controlling 4DC1, the auxiliary contact of 4DC1 used is a normally open contact, idiapa 4DC1. So when 4DC1 closes, time A, it will start timing out. Okay, and then when it reaches that preset value, yalachta influencing the main drive. Okay, by way of where's 4DD1? Where are you? Are we right in assuming that? Okay, so 4DD2 will come right about, where are you? Yes, here. So this is 4DD2. So you've got the lubrication pump running, and then there's a timer which delays for the crusher to start, because to learn that 281 is the one, if you see on the far right hand side here, the auxiliary contact of 281 is the one now which controls the power contactor for the main drive. So when the crusher main drive is actuated, okay, when this power contactor for the main drive is energized, then the crusher will start. Now the reason why there's that delay, you have to appreciate the fact that the crusher has got so many mechanical parts which needs lubrication. Okay, you can't run the crusher when the lubrication pump is not running, which is why there's that delay, so that paria lubrication pump ileamba mwachitako delay panono for the crusher to come in. By then we anticipate that lubrication oil nishi na ishita circulate mu system. Okay, so which brings us back to 3BD5. So when the crusher delay timer by way of 4DD2, when that timer times out, this normally open contact in this position, 4DD2, is going to close, right? When it closes, what it means is that at that point, there's already flow system, okay? So, ngamudi flow, E3BD4. 3BD4 is the auxiliary contact of this control relay, 3BD4, okay? So, this you see that is actually controlled by ama contacts. Yama flow switches, yalatwalela ndapo mudi piping and instrumentation diagram, the two flow switches. Yadi kwetama auxiliary contacts. So, at the point where there's flow, yala isarika, then even this one will close, and then this 3BD4 will be energized. Now, if 3BD4 is energized within the time that the timer value for 4DD2 hasn't elapsed, then yala isukapa. Mamona de yala isukapa. Then nga isulapa, even if 4DD2 times out and it closes there, then 3BD5 is not going to be energized. But if at all it had 4DD2, the main drive delay timer yashita timeout. I timer ngashita timeout yaisa isala, meaning this timer here. If this timer times out, the main drive delay timer times out and closes this point, what it means is that yala isali kampa, and then 3BD5 is going to be energized, okay? If 3BD5 is energized, it will come here. It will close, the auxiliary contact of that will close this position, energize 4DD1, which is a 4th trip auxiliary relay. And then when 4DD1 is energized, you notice that 4DD1 will shut down both the lubrication pump by way of this normally closed contact here. So energize 4DD1 control relay, the normally closed auxiliary contact in this position between 4D3 and 4D4 opens. Ngai suka clearly lubrication pump bala iminika. Mamonate. And then on this other side, you notice that 4DD1 is also going to open this position. Okay? It opens this position, meaning the sequence control relay bala ishta de-energize. Ngawa ishta de-energize, do we have 4DD1 affecting the main drive? Okay? 4DD1 is not directly influencing the main drive, but what's influencing this is the sequence control relay. Okay, the sequence control relay. Let's say 3BD1. So when 3BD1 is de-energized, 3BD1 is a sequence control relay, which is this one. When it's de-energized, it's going to open this position for 3BD1. So even the crusher, the main power conductor for the crusher is going to be de-energized, and then the system stops. Okay, but let's assume there's a fault moody crusher by way of 283. So 283 clearly is going to stop the main drive. Okay, the main drive control, this is going to be disabled. Okay, if this is energized as a result of the thermal overload and earth leakage, then this then control relay is going to be energized. It's normally close contacts are going to open. So 283 used in which position? 283, where have you been used as a discrete protection? Okay, let's see. 283 is just used in 4. Okay, so 283 is used in network or rung 4. Okay, 283 rung 4, 283 is going to open there, right? When it opens there, the sequence control relay is de-energized, but it has no bearing on the immediate stopping of the lubrication pump, because apamwala monati in this sequence, what it is the sequence control relay. Okay, when all the system is healthy, you press the system start, and then in that instant 3BD1 is energized. It seals in through 3BD1. At the same time that 3BD1 is being sealed in, the loop control timer 3BD2 is going to start timing out. Okay, and the reason why this timer has to time out is because 3BD1 has got auxiliary contacts. I have rung 7, this rung 7 here. Okay, so when 3BD1 is energized, it closes there, and the pre-start warning alarms muloko station na remote station ya alamba for a specific duration. Okay, So yamba byaledi lafine, so that siren will stay on, right? So at the point where 3BD2 is timing out, and assuming that the loop circuit is healthy, this 3BD2, the auxiliary contact, and is going to close this in this position, assuming you are in the normal position, right? You're in the normal position, and then of course you've closed the main contactor, okay? The main isolator for the system has been closed, and the auxiliary contact is being used in this position. So that auxiliary contact, yala isadika hapa, you go down, 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 system is healthy, 4DD1 is closed, okay? And then 3BD6 is healthy, meaning this emergency push button is not actuated, it's just healthy, okay? So this will be closed also, because the normal state of 3BD6 is energized, and if it's got normally open contacts, that normally open contact will be in the closed position between 4D4 and 4D5, so to be closed. And then you need to be in the normal position. So you are in the normal position, so that at the point where this timer 3BD2 is timing out, it's just going to close there. And then when it closes, this clutch timer is engaged, okay? So the clutch timer essentially provides a delayed de-energization of the loop pump, okay? So that when you're switching off the system, the loop pump stays on until the crusher comes off, okay? So the crusher is powered down, but the loop keeps running for a certain time, okay? But the only thing to notice, the way they've used 4DD3 in this network or rung 11, you notice that there's a timed contact which is normally closed, right? And then you can set this between 0 to 6 minutes. This, how you set this is dependent on how much time you think it's going to take for you for that lubrication oil to flow through the system, okay? And then there's this other contact which is ICIO, okay? ICIO, the simplest way for you to think of this contact is, if without this contact, okay, in this configuration, what it means is, if the system is healthy from the power run, from this run, if the system is healthy, meaning you've got 110 coming, past the normal select, at this point, without this normal open contact, then the loop pump would start, okay? That's the problem. So what we want is control over when to energize this power contactor coil, okay? So what's going to happen is, we used this normally open contact, which is also part of the clutch timer, okay? This whole arrangement in this square thingy here is actually a clutch timer representation. So what's going to happen is, when this contact closes, the instant this point is energized, okay? The instant this point is energized, and 4DD3 at position 1 as a supply point, okay? Like 110 shows up across the coil. This contact in this rung 11 is going to instantly close, okay? It closes. And then of course, when that closes, what it means now is a 4DC1 as a loop pump is going to start running, okay? So the loop pump starts running. This will come into play at the point where you either press the system stop, normal system stop, okay? So you press the normal system stop here, between 3BD10 and 3BD11, you press the normal system stop, you de-energize the sequence control relay. At that point, 3BD2 is going to be de-energized, okay? When 3BD2 is de-energized, it's going to open its normally open contact in this position. In rung 10, it's going to open. When you lose the voltage across the coil, this coil, 4DD3, the clutch timer now is going to delay the operation of this contact, okay? It's going to delay the operation of this contact, of this arrangement, okay? If you've set, let's say, 2-3 minutes, this is only going to open after 2 minutes, okay? Thereby allowing you a delayed switch off of the lubrication pump. So that's just how that part works, okay? So normal system stop, you go through the normal sequence of stopping. And then, of course, we'll talk about the different levels of protection. We're saying E3BD6, it will open both the sequence control relay, de-energize the sequence control relay, and it will immediately shut down the lubrication pump. and then it will shut down the main drive by way of de-energizing 281 if it was running. Okay, that said, if we look at a fault such as 283, this 283 is just going to open the sequence control relay rung. Okay, it's going to open this position. There's a fault in the crusher main drive, it opens there, and then the sequence control relay is going to be de-energized. But it has got no direct bearing on when the lubrication pump stops. What does in the lubrication pump is the sequence control relay de-energizing. Okay, it's more like the after effect. Like it's not just going to stop the lubrication pump right there and then, but it's going to allow the lubrication pump to go through the sequence. Okay, it will say, okay, fine, I know that the crusher has stopped, but I need to delay the operation for a certain preset time, which if we're to land that in 2 minutes. Okay, you can set anything you want depending on what your system is all about. Okay, so if we're to land that at that point, 283, no direct effect on the shutting down of the lubrication pump, but rather it just sets into motion a normal sequence stop. Okay, but then you notice that any fault to do with the lubrication pump by way of 4DD1 is going to shut down the lubrication pump itself, and then it's going to shut down the sequence control. Okay, the sequence control relay is going to be de-energized. So just by that alone, you notice that all the faults related to the lubrication system have the same effect as the safety relay. Okay, they'll have the same effect in that they'll shut down the whole system. Okay, but a fault that has to do with the main drive, okay, by way of 283, by way of this 283, is only going to open the sequence. It's just going to function like a normal system stop. It's going to open 283, normally close auxiliary contact between 3B1A and 3B5. It's going to open this, and in a way, working just like a normal system stop, the system goes through the normal sequence of stopping. Okay, now you may wonder to say, okay, at which point does the pre-start warning alarm get to stop? Okay, because when 3BD1 closed, we left the alarm running. Okay, these pre-start warning alarms were on, and then the only way to stop the pre-start warning alarm is by opening 281. 281 is a normally close contact of the main drive power contactor. It's got these auxiliary contacts. Okay, so 281 is the power contactor for the main drive. You can either directly control the power contactor for the main drive, or you can go through a control relay which then controls the power contactor for the main drive. Okay, but the whole point is 281 has got associated auxiliary contacts. So at the point where you're saying that the main drive starts, okay, if the main drive is going to start, by way you come from this part of the control, the system is healthy, the main breaker is closed, so these auxiliary contacts are normal open auxiliary contacts are closed. You come down, there's no thermal overload, there's no earth leakage fault, so you come down, it's healthy. And then TR is just the thermistor relay for the main drive, essentially talking about temperature protection. Okay, if it's healthy, we assume that under normal condition this contact is supposed to be closed. So you're coming down, 3BD3 was the loop oil temperature, I think. So this 3BD3 is the loop oil temperature. The loop oil temperature is normal, you close there. 3BD6, you haven't pressed the emergency push button, so this is healthy, you come down here. 3BD4, we are saying there should be a flow in the system. Okay, this is 3BD4, flow switch 1 closes, flow switch 2 closes, and 3BD4 is de-energized, and this closes right there. Okay, so which is where you notice that if there's no flow in the system, you cannot run the crusher. Okay, you can't just run it like that. So there needs to be flow in the system. 3BD4 is going to be closed. 3BD1 is the sequence control relay, like we previously saw. It's there, and then you're in the normal position, and then the main drive delay time has timed out, so this closes, and there you go, your main drive has started. So that's how this is going to work. Okay, so APA, of your level. So the whole point is we can think of protection as being in two levels. Okay, we can think of level 1 protection, which basically disrupts the normal system stop sequence. Okay, level 2 is a fault, yes, but it stops the system by way of the normal sequence. Okay, so level 1 disrupts the whole sequence of stopping, meaning you get a level 1 fault, or you actuate the emergency push button, the crusher main drive motor will stop, then the lubrication pump motor will stop irrespective of the sequence. But if you get a fault, which we are going to refer to as level 2, in that case it's going to just function as a normal system stop in a way, right? Because it's going to just de-energize the sequence control relay and allow the system to stop normally. It's going to just allow the lubrication pump to power down following the sequence, as opposed to the level 1 protection, which just shuts down everything irrespective of the determined operational sequence. Okay, so my point is, when we create our logic, we are first going to create two functions, right? Here first twalaita ati level 1 protection, here second twalaita ati level 2 protection. Okay, we don't have to, but we're just trying to have fun with this. Okay, so that said, we're going to insert an object, insert function, the language, okay, let's use ladder, and then protection, symbolic name, we're going to say protection level 1. Okay, what do we have to say? It's, apparently, I don't know, maybe I'm online or whatnot. So we're going to call this as level 1 protection, and then we're going to insert another function. Okay, or maybe let's just copy this. We can copy, and then we can paste this, rename, we'll call this function 6, and then object properties, and then we're going to say protection level 2. Okay, this okay, no, we need to call this in OB1, but for now let's just skip that part. Code block open. What is happening here? You're lost. It's just open. You're lost. You're like code block open, but you're not in the OB. What's wrong with you? So options, view, overviews. Okay, this is what we get. So this is level 1 protection. Let's do this, and let's do that. Okay, so that we see them side by side. Level 1 protection. Essentially, we're saying that we need all those functions or inputs which are going to stop the system immediately, irrespective of the sequence. So clearly, in rank 3, we just need what is being termed as a safety relay, right? We just need what is being termed as a safety relay. So we're going to insert how many normally close contacts? 1, 2, 3, 4. Okay, I don't know what NDR is because it wasn't really explained. There's no legend to explain what NDR was. Okay, so 1, 2, 3, 4, and then an output coil. Okay, and then what do we have? This is an emergency insert symbol, station 1. Okay, if I remember correctly, station 1. Insert symbol. Okay, should I just say station 2? But we need memory addresses. Okay, so this is station 2, and then we need station 3. We need station 3, and then we need station 4, right? Like so. And then we're talking about 3BD6. Okay, so let's see, 3BD6. 3BD6 is right there. So this takes care of the first rung, okay, the one which is rung 3, okay. So the other thing we need now is just insert a network, and then we're going to think of which other system. So 3BD6 is here, and then 4DD1 is here, okay. So these are level 1 events, level 1 protection events. So let's look at 4DD1 like so. You notice that 4DD1 is actually what? Is actually a consequence of there being a fault in the loop system, okay. So this is the lubrication pump. So 4DE3 and 4DE2 are respectively the thermal overload and the earth leakage protection for the lubrication pump, okay. So this lubrication pump has got these two protections, okay. And then 3BD5, like we previously said, was a no flow condition, okay. So it's also a level 1 event, because any fault that has to do with the lubrication pump is a level 1 protection event. So which is what we have in here, protection level 1, okay. So apano mbapa, anyway, we just use them the way they are. But if you wanted to have fun with this, the question would be, what's the normal state of these inputs? Like, what's the normal state of 4DE3? What's the normal state of 4DE2? When we're talking about a PLC, essentially we say externally, right? Externally, we're going to wire these protection functions or protection instructions or protection signals through normally closed contacts of these devices. So we're going to go to the thermal overload, use this normally closed contact. We're going to go to the earth leakage protection device, use this normally closed contact, then wire those signals back to the PLC, okay? So when those signals come to the PLC, they are essentially true state conditions, okay? So inside the PLC, they'll be like true state, okay? So that said, what we can do is this. We can use normally open contacts, right? Of which one we're going to call 4DE3, okay? So 4DE3, we're going to go 4DE3. I know in this they're connected in parallel, but let's have fun with them and just connect them in series. And then there's 4DE2, 4DE3, 4DE3, 4DE2, and then of course there's 3BD5. Okay, there's 3BD5. So 3BD5 is never supposed to be energized. Okay, when 3BD5 is energized, it means the system has confirmed that there's no flow. So if it's never supposed to be energized, we use it as a normally closed contact, and then we're going to say 3BD5. Okay, going to say 3BD5, and then right after that we've taken care of 4DE3, 4DE2. Now let's say 4DE2. Maybe let's be more systematic. Let's go 4DE2, 4DE3, then 3BD5, and then of course they're saying we need to have a fault reset. Okay, fault reset, system fault reset. Okay, system fault reset, system fault reset, and then we're going to have an output coil which is designated as what, 4DD1. Okay, 4DD1, like so, which is this one here. Okay, fault reset, and then they're saying we need to seal in through what? Through 4DD1. That we can borrow. So there are two ways we can do this. Okay, let me just show you what I mean. We can choose to go through. We can do the same thing, but we could have done it like this. Okay, we can do it like this. We can do it like this. Okay, you're not Rockwell. Okay, you can choose to do it like this so that we don't have to sail in through 4DD1. Okay, but then we wouldn't be needing this. Okay, we wouldn't be needing this. But what are we saying? True, true, true. So the result of logic operation in this position will be true. This will be set, but we only need for this to be set under fault conditions, right? So we're going to negate the result of logic operation after 3BD5. Okay, so what it means is if the signal state of this is true, true, and if this is not energized, the result of logic operation before the negation will be true. So after the negation, it will be false. Okay, if any of these for whatever reason is false, the result of logic operation before negation will be false, and then afterwards it will be true, and then you're going to set this. Okay, so that's one way we can accomplish this, right? And then of course we're talking about the indicator lamp akakalaiti babikila part 4 indicator. No biggie. What we can do is the following. Here's the following. Let's see. Okay, you normalize. Okay, and then negation. But in this case, we're saying we need, the reason why we're doing it like this is because we need a level of control over this. But here's the thing, okay? Here's the thing. If you remember the way we've wired the inputs, okay? The way we wired our inputs, and when we spoke about input, when we spoke about input validation. Okay, so this, yes. So when we're talking about input validation, essentially whatever input there was, and if it was a protection function related, like if the input had anything to do with protection, we needed to reset to normalize the system. Okay, so once that transition, like if there's a fault in the system, a fault in the lubrication system, the faulted state will be latched by way of the configuration we have created in these networks. Okay, in these networks. So that's essentially what's going to happen. So you'd notice that actually we don't need to worry about this. Okay, because of where we've come from. We know that if there's a fault, let's say by way of the earth leakage or thermal overload, that state, the faulted state, as passed on to the system is going to be latched. Okay, so that we need to reset to normalize. So which brings us to what situation this is. Okay, so me, I'm trying to claim that normal state, I'm saying, is supposed to be true, and if this is okay, it's not, there's flow, this won't be energized, so the result of logic operation at this point will be true. Okay, and then this won't be set. Okay, so that's the thing I'm trying to say, right? But the thing is, would it work if we said, for instance, that as opposed to using a set instruction, okay, as opposed to using a set instruction, we just delete this, okay? We just use a normal output coil, okay? There's nothing wrong with that. It can still work, but I'm thinking this would be more ideal considering what we have configured with the latching of the inputs and all that, okay? Because if any of these get into a faulted state, this won't reset, okay? So we get another output coil, but this time we're going to assign the fault indicator lamp for the lubrication pump. It will at 4DH1, okay? So 4DH1, okay? Like so, okay? This is what we get. Then of course we don't need this as it is. I know it looks different, but I've done this based on where we've come from. Again, let me repeat myself. I'm saying that when we're talking about input validation, we said that all those functions which had to do with protection, we were supposed to monitor the transitions in their state. Meaning, if there's a fault in the thermal overload, if there's a fault in the earth leakage protection, or there's a fault in any other protection aspect, there's a transition in the emergency push buttons. To normalize the PLC input signals, we needed to reset. So if there's any of these coming through as faulted states, these won't change state regardless of whatever happens external to the system, right? And because we're using a negation instruction in this position, if these became change state from true to false, meaning the result of logic operation at this point will be false, okay? And then after the negation, it will be true, and then you get your signal here, lubrication pump status faulted or healthy, in which case we're saying that this is the fault trip auxiliary relay. So this is going to be energized, and then you know that the system is faulted, okay? And then of course you get your indicator lamp right there, okay? So that's how this is going to work. I've done this. It looks different, and you may say, oh, but why don't we have a reset push button? Well, because you can only normalize the system by resetting the input conditions. That's what I'm just trying to tell you, okay? That you have to think way back to what we said about the input validation. What happened in the input validation, and how I showed you that the signal change or the signal transitions were only affected by pressing the system reset, okay? This applies to this because these were also mapped in the input validation function, okay? So this takes care of that. So we are good to go with this network here, okay? Or this run if you want. So the other thing that will be of interest, so we've taken care of this branch. It's of no problem, okay? And then of course we've taken care of 3BD6 in network 1. In this particular case, we're saying normally open across parallel connection, normally open like so, and then it's going to go to a reset, okay? We need a reset. We've done this part, then we need 3BD4 as normally closed, okay? And then of course we have 3BD5, okay? So this one here becomes 4DD2, okay? So I think we did label this as 4DD2. 4DD2 under timers. What did we say about 4DD2? Why is it like this? It's a timer, main drive delay timer, okay? So main drive delay timer was 4DD2, so meaning 4DD2 was classified as what? Just 4DD2 was classified as just an output coil for that timer, okay? So we need to assign this output to that particular timer when we get to that, okay? So that takes care of 4DD2, and then of course 3BD5, and then what do we need? 3BD4, and then we've got system fault reset. Got a system fault reset, and then of course we've got 3BD5, okay? Got 3BD5. So we've taken care of this, right? Because we've got the loop over failure relay. I think this is just a reset, which we're calling the system fault reset. And then there's an OR configuration or a parallel configuration between 4DD2 and 3BD5. So 4DD2, 3BD5, and then in series with the flow, okay? The flow relay, okay? The flow control relay, because 3BD4 is only energized as a consequence of there being a flow. So flow switch 1 closes, flow switch 2 closes, and then 3BD4 is energized, okay? So we have this. Main drive delay timer. So by the time the main drive delay timer is closing, there should be flow. Okay, that's just what this is saying. Main drive delay timer, when that timer 4DD2 times out, it's going to close here. And then at that point, if there's no flow in the system, 3BD5 is going to be energized. Okay, so we have this. This whole thing here is this one in the PLC. Okay, so this is 3BD5. We've taken care of 3BD5 as a system level event. So this is 3BD5, and then of course it's supposed to also be in the lubrication control, okay, which is why it's a level one protection event. 3BD3. So 3BD3 is what? Is loop oil temperature. Okay, so loop oil temperature is this one here. I'm calling it the loop oil temperature because of the way it's being brought in. Loop oil temperature switch, then there's 3BD3. So this is basically the control relay monitoring the condition, the temperature condition of the oil. Okay, so if it's being used in this condition, it means the normal condition of 3BD3 as a control relay is supposed to be energized. Okay, 3BD3 is not affecting, has got no immediate effect on the operation of the lubrication pump, because if you see in this run, there's from top we just have 4DD1, 3BD6. There's no 3BD3 anywhere in this. Okay, so clearly this our 3BD3, Imamona 3BD3 is not a level 1 protection function, but level 2. Okay, level 1 has to stop both the crusher main drive, and then it has to stop the lubrication pump irrespective of the sequence. A level 2 protection function, according to us, is just supposed to stop the system normally, in the sense that it's not a fault directly related to the lubrication pump. It's a fault directly related to the operation of the main drive itself. Okay, whether thermal overload or earth leakage or whatever it is. Okay, so we know how we're going to deal with this one, and then we know how we're going to deal with 283. We've dealt with 3BD6 and we've dealt with 4DD1. Okay, and then going downstream, we don't really have anything. Okay, so in as far as level 1 protection is concerned, I think we're good to go. We've taken care of every conceivable event. But for 3BD5, do we have an indicator lamp? Okay, so 3BD5 is used here. 3BH2 as a loop oil flow stopped indicator. Okay, so we're saying if we energize, we can do we can do it like this, put an output coil, and then do what? 3BH1, is it 3BH2? Okay, so we can do 3BH2 like so. Okay, now 3BH2, and then pause. Okay, so we've taken care of the lubrication overflow stopped indicator, okay, which is the one associated with the auxiliary contact of 3BD5, but internally in the PLC we just do it like this. Okay, what do we have? What else do we need? Again, at this point you're like, but why are we using a saline contact? Because the difference is these contacts, okay, these are a consequence of being physical inputs, okay, which is why they're already mapped in the input validation, and that input validation at that reset function configured in that particular network, okay, which is different in this case because all of the associated addresses in this network are basically resultant conditions, okay. They are not physical inputs, so that's the difference, and that's why we need to sell in like the way we've just done, okay. So upper, we've taken care of run what? We've taken care of run 24, which is the loop overflow interlock 3BD5, and we've taken care of the one which is talking about the indication, okay, loop overflow stopped indication 3BD4. We're not going to leave 3BD4 in this function, which is being called protection level 1, okay. So we're not doing anything with this run here. Run 21 will not be touched, okay. And then 3BD3 is actually a level 2 protection event, because if the lubrication oil temperature is high, it's just going to stop the sequence control relay, and the system will stop normally, okay. So it's a level 2 protection function. So we were not going to deal with run 19 and 20, but rather just run 24 and 23. Then after that, the loop off filter bypass switch is not exactly being used for protection. It's just being used as it's just being used for indication. Okay, it's not being used anywhere. I think that's true. Yes. Protection level 1, we just have these. Okay. Now the beauty of doing it like this is that if you needed any other protection function to be incorporated in the system, you'd know at which point to insert it. Okay. So now what we'll do is we'll get to answer one very fine question. Okay. What's the normal state of 3BD6? Okay. 3BD6. In this particular regard, I feel we need to use a negation, okay? Because the normal state of these, because of the mapping that we've actually done, okay? Because of the mapping that we have done, or rather, let me just show you something so you're not like, oh, but what are you talking about? So this is protection level 1. I'm going to close it for now, okay? I'm going to close it for now. Protection level 1 needs to be called in OB1, okay? Go to insert a network, and then functions protection level 1. I think this is protection level 1. We need that, okay? This is station 1 emergency, okay? Station 1 emergency relates to this one here, okay? But you notice that the signal state being passed on to the station 1 emergency stop memory bit, because we are programming using memory bits. What's being passed on to this is a false state, okay? This only attains a true state if you actuate this, okay? It attains a true state if you unlatch, still true state, okay? But you need to reset to get the actual, to reset the faulted state of the system. So Mukati, because of the way we did the input validation basically just makes it so that you want some signals to do with protection, which we are wiring through normally closed contacts. When they come to the PLC, we pass them through the networks for input validation. On the output side, the healthy state is supposed to be the false state, okay? I hope that makes sense, okay? I really hope that makes sense, because if you understand that, then that will explain why this is like this, okay? So where external protection instructions are concerned, we need to negate this state, okay? So maybe we just copy this, paste there, and then download this again, okay? So that now 3BD6 we'll have a false state. Okay, and then what else do we need? We're being told that we haven't mapped. Okay, I think it's the same. It's the same thing with 4DE2 and 4DE3. Okay, it's the same thing with 4DE2 and 4DE3. So let's look at 4DE2. Okay, let's look at 4DE3. Okay, so we're actually getting those signals. Okay, so essentially what it means, ladies and gentlemen, is that if we're going to use these protection functions internally in our logic, then we need to be wired as normally closed contacts and not normally open. Okay, so that's our truth, like so. W needs to be done like this. Okay, so now this takes care of our little issue. Okay, now what I meant when I said we don't need the reset in this function, okay, or in this network, was this: if 4DE2 is actuated, okay, you notice that the lubrication pump status faulted or healthy, this lamp will come on. Okay, and it will stay so even if I normalize this. Okay, nothing happens, right? Nothing happens unless I do a reset. Then that's when the state changes. Same thing, it may look different, but it functions in the same way. Okay, so that takes care of this. And then for 3BD5, what are we saying? 3BD5 is okay like this. It's supposed to be in this de-energized state, right? So what this means now, ladies and gentlemen, if we're going to get out of this protection level 1 function, what it means is we just use normally closed contacts. Okay, de-energized. Okay, de-energized, then the output, and then options symbol table. On the output side of things, we went as far as memory bit 103.0 as a normal output. So let's do insert symbol, and then this we'll just call it protection level 1. Okay, then I know at some point we may need to come back here, insert symbol, then copy that, paste there, protection level 2. Okay, and then we'll save this, close that, so that now all we need is we'll get this, paste there if you want, get this one here, paste there, get this one 3BD5, paste there, and then protection. Okay, protection level 1, and then we need to negate. Okay, seeing as how we already have this, we'll get that true, false, like that. Save this, download. Okay, and then we have something like this. Okay, so when the system is healthy, okay, what this means, ladies and gentlemen, is that when the system is healthy, like everything is okay. Okay, so wherever we need a level 1 protection event, all we need is to come and pick this, slap it on there, and we're good to go. Okay, so if the program was to grow, you're going to introduce other additional protection functions. You just come in this particular function 5, add your network, add your condition, and just still maintain the protection level 1 contact wherever you've used it. So how this is going to work: station 1 EMR, this one here, actuated, and then protection. Okay, so we've got a level 1 protection event, and the consequence is 3BD6. We go to where 3BD6 is. We see that station 1 emergency stop has been actuated. We come back here in factory IO, reset this. We still have the situation persisting do a reset, the system resets, and we're good to go. So what it means now is that instead of having these funny things like 3BD6, 4DD1, 3BD5, we'll just have a single associated contact of this address, memory bit 103.1, protection level 1. Okay, and that's that. So we move on to the second function. Okay, so we just need to move on to the second function, which is that of protection level 2. Okay, like as always, we need to insert network, get to functions, protection level 2, drag it on there, save this window, protection level, code block open, okay. So we're here, we do the same thing. Okay, we're going to do the same thing. And what we're going to do is we're going to come here and pick all those level 2 protection conditions. Okay, so we said 283, 3BD3 were level 2 protection. Okay, so we're going to start with 283, which we're going to get from the main drive. So we're going to go to the main drive, go to the main drive and look at 283 first. Okay, so 283 is this one here. Okay, 283 is this one here. Whatever this thing is looking at, oh, but it's so complicated, what are we going to do? Okay, we really don't care. The only thing to note, we need to pay attention to is, we said the TR. Okay, this is a thermistor device for the main drive. That motor for the main drive, for the crusher main drive motor has got a thermistor installed. Okay, so that you're able to monitor the temperature and everything else. And then you notice that 283 is never supposed to be energized, because if 283 is energized, then what's going to happen is 283 will open this network or this run, and then you won't be able to start. So the normal condition of 283 is de-energized. Okay, that's what you need to remember. So the thermistor, we're using a normally closed contact. Okay, if we choose to use a normally closed contact as a signal to the PLC, it will have the same effect as any other protection function. Okay, the same thing goes for the thermal overload and the earth leakage protection for the main drive. Okay, so what do we do? Okay, so let's do close. Do we do negation exactly like the other one, then an output? Okay, so we know that, what do we have? We have H5 to AE1. Okay, so hopefully I get to see it early. We've got 2AE1, and then we've got H5A. We've got H5A, and then what do we have? We've got TR. Okay, that's TR. Main drive thermistor relay TR. What's your issue? What's this? T01. Okay, so it's supposed to be temperature. We bought temperature. Okay, so the one we want is the main drive thermistor relay. Okay, so I think this is it. The main drive thermistor relay TR02. Main drive thermistor relay as an input. Okay, so that takes care of this TR, right? And then of course we need to control 283. Okay, so we need to control 283, and that's the end of this. Okay, once again, we don't need to worry about the reset. Okay, even though the reason why there's no reset in rank 33 or rank 34 is due to the fact that this device here, the one which they're calling P&B gods, H5A relay is a physical protection relay, meaning if there's either an overcurrent or a fault event, you need to go and physically reset the relay. So that's why you're going to do this reset business. Okay, so we've taken care of this, and then we've taken care of the thermistor, and then we've taken care of 283. So the only thing we need to take care of is 2AH1. Okay, again, we can either do this, put an output coil, call this as 2AH1 like so. So that takes care of the fault trip indication lamp, and that takes care of 283 as a fault trip auxiliary relay, as so called. Or in this case, we can just think of it as a fault relay with fault output coil for the main drive, as implemented in the PLC. Okay, so this takes care of ichichiri apa. So we've basically nailed all of this. Okay, we've nailed all of this. Okay, and then what else? What else do we need? Okay, 3BD3. That's a level 2 protection. Okay, so don't need to worry about that. The key thing is we've taken care of this part. Okay, so let's go to the left. Which event qualifies as a level 2 protection event? So let's insert a network. Then we're talking about the loop board temperature. Okay, let's do what? The loop board temperature 3BD3. What's the normal state of this? 3BD3 is used in 420 and 29. This is supposed to be constantly energized, so we can do with a normally closed contact, and then we can use an output coil, loop board temperature switch. So T. What do we have? Loop board temperature. Okay, T0102 was normally closed. Okay. Loop board temperature. Okay, let's see what you have. Loop board temperature. Okay, lubrication or temperature. I bet this is what this is. So when we say loop board temperature, again, you need to understand that whether it's a thermocouple or an RTD is going to be connected to a temperature controller. That temperature controller is going to have auxiliary contacts. We use normally closed auxiliary contacts, wire them to the PLC, and then apply that to the input validation, meaning on the output side of that input validation, the output signal is going to be false. So we need to use it as normally closed here, and then assign 3BD3. Okay, then assign 3BD3 like so. Okay, so this takes care of this run. Okay, and then of course in the next run we're talking about loop oil temperature high indication. If this is used as a normally closed contact, meaning the normal state of this is always energized. Okay, so if we're going to accomplish the indicator lamp, we can do it in two ways. Okay, we can either negate. Okay, we can negate this. We can do it like so, and then use an output coil like so, and then we'll say 3BH1. Okay, so 3BH1 like so. Okay, we can do it like this, or if you did not want to do it like this, okay, if you did not want to do it like this, you could have done it like so. Could have done it like so. It's the same thing. Okay, and then you do it like this. Essentially what we're just saying is the normal state of this is energized. Okay, so when this is energized, meaning the output coil with the bit address M100 and 1.3 is going to be true. If this is true, this is going to open, so that the result of logic operation at this point will be false. And then when there's an over temperature externally, that input signal will be false, and then of course this lamp is going to be true. Okay, this only makes sense if you take time to understand how the input validation works. Okay, so this takes care of the lamp, the loop over temperature high indicator. Okay, the only other thing we need to configure is the flow. Okay, so flow doesn't directly fall under level 1 or level 2, okay, but it does influence a level 1 event, as in brought about by 3BD5. Okay, because if there's no flow, or flow is not confirmed but the lubrication pump is running and the main drive delay timer is timed out, then 3BD5 is going to be energized, and when 3BD5 is energized, it will de-energize both the normal sequence. Okay, so 3BD5 is going to open the sequence control relay, and then yes, here. Okay, so 3BD5 closes, declared as a fault. 4DD1 energized, 4DD1 opens this, and 4DD1 opens that position. So level 1 protection event. We know that the flow is a key element as a condition for 3BD5, but for now we're not going to classify it as a level 1 protection event or as a level 2 protection event, which means now we've taken care of this rung 19, we've taken care of rung 20, we've taken care of rung 23, taken care of rung 24, and then we've taken care of rung 33 and 34. Okay, and then in as far as the, let's see, 2H1 is done. This is 2H1, 283. So this is done. So where level 1 protection events are concerned, level 2 protection events are concerned, we're done. Okay, so we just need only insert a network and then do the same thing we did previously, like normally closed, output coil. Or do we negate? We also need to negate. Okay, we need to negate, and then output coil. Okay, so we're going to have 283. Okay, so this is 283, then 3BD3, this is 3BD3. So it's just these two conditions which qualify as protection level 2, right? So if you've got any other level 2 protection events, you come and add them from here. Okay, so that's done, and I think we've already called this in OB1. So protection level 2, protection level 1. So let's download this to the simulator. Okay, that's done. We just need to look at level 2 protection. Then let's monitor this. Okay, low bore temperature high. Okay, so this is basically the behavior we expect, and then this is what low bore temperature high. T0101, T0102. So was this mapped externally? T0102, let's see. Yes. So this was T0102. T0102. So this was actually mapped. Okay. So if T0102 normally closed this, and then wherever we use them in series, we need to negate. I mean, there's a whole lot of negation going on. Okay, so because we said we need to use this as a, 3BD3. Better we use it as a because in the electrical schematic, in this schematic 3BD3, the normal state of 3BD3 is energized. Okay, so like this, 3BD3 is energized. That's the normal state. We've put it into the PLC. Now 3BD3, this is the normal state. Okay, so if this has to work out and we don't want to use the negation in this network, what we can do is we can use a normally open contact in that position. Okay, delete this, and then we have something like this. Okay, so that if we have an over temperature in the lube system, in the lubrication oil, like so, you have this thing called a level 2 protection event, and then you'd come here, and then this lamp which is saying lubrication oil temperature high indication is going to be true, so that you know that the temperature is actually high, so that if there was a loose connection in the system and then this normalizes somehow, the system will still remain latched, so that you need to come and do a reset, right? So that takes care of level 1 protection and level 2 protection events. The reason why we have done it like this, now it's scalable. You get any other condition, identify it. Is this protection level 1? Is this protection level 2? You add that to the specific function, and you're good to go. Okay, so this basically ends this classification of whether a protection function is level 1 or a protection function is level 2, which signal qualifies as a level 1 event, level 1 protection event, which signal qualifies as a level 2 protection event. So hopefully in the next part we just talk about sequence. Okay, so tukabonana. Cheers.